in 10th class, generally in a real numbers chapter, you will be asked to prove that root 2, root 3, root 5. These numbers, they will ask us to prove these numbers as irrational numbers. You have already learned what are rational numbers in 9th class itself very clearly, and about rational numbers you have learned in 8th class, right? So we have to prove them as irrational numbers. So now let us take root 2. So what we have to prove? We have to prove root 2 as irrational number. So instead of that, let us consider root 2 as a rational number. So you have tried. Let us consider root 2 is a rational number, right? So as we have considered root 2 as rational number, so root 2 can be written in the form of p by q, right? A by b, right? As you have learnt in 8th class. And also you have to mention a comma b are integers, means a comma b belongs to z. A and b belong to the set of integers, it means, and a comma b are co-primes. Either you write co-primes, right? Or else a b are relatively prime, all means the same. Relatively prime, or else HCF of AB is 1. You have to, and also you have to mention B is not equal to 0. However, it is not important here, and B is not equal to 0, right? So now you should know what are co-primes. These three mean the same. So if the HCF of any two numbers is 1, those numbers are called co-primes or relatively primes. So for example, if you see 4 comma 9, is 4 a prime number? No. Is 9 a prime number? No. But their common factor is 1. Right? What are the factors of 4? 1 comma 2 comma 4. What are the factors of 9? 1 comma 3 comma 9. What common? 1 is common, right? So that is why their common factor is 1. Highest common factor is also 1 only, right? So if the common factor of any two numbers is 1, highest common factor of any numbers is 1, they are called relatively prime. By this example, we should have in mind very clear idea that even if the numbers are not prime numbers, they may be co-primes. They will be co-primes, right? They may be co-primes, right? Like this 4 comma 9. So you have got clarity what are co-primes, right? Now, so we have considered root 2 is equal to a by b. Either you square here itself, or after sending b this side you can square. It's up to you, right? So let us take b another side. So b into root 2 is equal to a. Now square on both sides, right? Implies square on both sides. So this will become b square into root 2 square is equal to a square, right? As there is no place, much place, I am writing here itself. So b square into 2 is equal to a square, right? Now, so now after this, what we say is 2 is a factor of a square, we will say. For that you need what are factors, right? So for example, if you write 2 into 3 is equal to 6. So here 2 divides 6 and 3 also divides 6. So nothing but product of 2 and 3 is 6 here. So here 2 and 3, whenever you write like this, these two numbers divide this number without leaving any remainder. Then these two numbers are factors. The definition of factor itself that a number which divides the given number without leaving remainder is the factor of that number. Right? These two are factors of this number now. Right? So similarly, 2 is a factor of a square. Right? Therefore, what we conclude? Therefore, 2 is a factor of a square. So implies here again you need some concept, right? So now let us take a number 36. 36 I can write as 6 into 6. So 6 into 6. How do you write 6? 2 into 3. I am prime factorizing 36. Simple. 36 is nothing but 6 square, right? So 2 into 3. Observe carefully here. 2 is a factor of 6 square. 2 is a factor of 6 square. 3 is a factor of 6 square. Then this 3, 2 and 3 are also factors of 6. Right? 2 and 3 are factors of 6 square. Then this 2 and 3 are also factors of 6. So it is applicable only when these 2 and 3, these numbers are factors. So for example, 4 is a factor of again 36. Right? But 4 is not a factor of 6. Right? 4 is a factor of 7, but 4 is not a factor of 6. That is why. So when a prime number is a factor of, let us consider this as a p. When a prime number p is a factor of a square, this p must be a factor of a also. So we can apply the same for a cube also. If a prime number p is a factor of a cube, then the p must be a factor of a power 4. We can apply the same, right? So here what we conclude is, therefore 2 is a factor of a. So again by this rule, here 2 is a factor for 6. 2 is factor for a. So that is why 2 into there exists some number is equal to a. So let this number be c. Right? For some c belongs to z. Right? No. Again square this. Or else substitute this into this. Or else square this. What you will get? 2c whole square is equal to a square. Implies 2 square c square is 4. C square is equal to a square. So this is 1. This is 2. From 1 and 2. From 1 and 2. From equations 1 and 2. B square into 2 is equal to 4c square, right, isn't it? So 2 ones, 2 twos, implies b square is equal to 2c square, right? You are getting, right? B square is equal to 2c square. Now again, how did we get? B square is equal to 2 into c square, isn't it? We got here as b square is equal to 2 into c square. Means what again? 2 is a factor of b square, right? From this again, b square 6 is equal to 2 into 3. 2 into 3. 2 is a factor of 6. Similarly, b square is equal to 2 into c square. 2 is a factor of b square. Therefore, 2 is a factor of b square. Implies 2 is a factor of b. From this again, from this rule, right? So therefore 2 is a factor of both a and b, right? What we got here? We got 2 as a factor for both a and b. But what we have considered here? As we have considered root 2 as rational number, as it is if it is a rational number, there will exist two numbers, two integers a and b, where a and b are co-primes, means their HCF must be 1 only. But we got here HCF as 2, right? Some 2 is we didn't get HCF as 2, but 2 is a factor of both a and b. This is contradiction, right? Why this contradiction occurred? As we have assumed root 2 as a rational number. So that is why, therefore, this is contradiction, as A and B here right here. This is contradiction to what we have considered, that A and B are co-primes, and therefore root 2 is irrational number. You mentioned, right? You have to write here. This is in contradiction to our assumption that root 2 is a rational number. That is why root 2 is irrational number. So thanks for watching. I think you have understood.